Hello students. So today we would be studying about two kinds of data structure that is used during programming. First is stack and other is queue. So let us first see stack into detail. So stack is a data structure, like we can associate a stack with a bookkeeping in library. Like how do we keep books in a library? Like let's say this is a table in a library, so books are placed on top of each other. So this is a kind of stack. So this we call a stack data structure, and in programming a stack can be implemented using an array, or we can even use a linked list for it. But let's go for an easy implementation. Let us say a stack is implemented using array. So this is a stack. Now let us see some of the terminologies that is associated with stack. So first of all, if we need to remove this book from the stack, we would need to first pick up this book, then this book, and then we can have access to this book. We cannot directly remove the last book from the stack. So here comes the concept which stack follows. So stack follows first in, last out. So whichever book or element that goes first into the structure, it would be coming out last from the structure. Now also let us see some more basic terminology. So if we need to initialize a stack, so for initializing a stack in a programming language, we would be requiring big O of n space complexity, and n is the length of the array or length of the stack that we want to initialize. So big O notations are used to denote the worst case time complexities in programming. Also, if we need to traverse a stack, so for traversing a stack is basically going through each of the elements. So it would require a 0 to n time complexity, and during traversing we are not using any space. So it would be only requiring a linear space complexity. Now there are two more concepts associated with stack. First is pop and push. Pop means popping the topmost element from the stack, and push is basically putting a new element into the stack. So now I would be writing the average case complexities for it. We can explore more, like there is worst case time complexity, there is average case time complexity, there is best case time complexity, but currently I would be exploring only the average case time complexity. So the average case time complexity of pop operation is basically 0 linear time complexity, because we would need to just go on the top of the stack and remove that element. And push also same, because we need to just go on the top of the element and then push a new element. So it would require a constant time complexity. Now let us study something about queue data structure. So what is a queue data structure? So queue is basically, let's say whenever we go to watch a movie, we need to stand in a queue and then we need to take our tickets. So queue is basically this, and like whenever we are standing in a queue to get our movie tickets, so what structure or what thing queue follows is first in, first out. Like if you are first in the queue, you would be getting out also first. So this is one of other data structure that we used during programming, and same for it. Like let us explore initialization, traversing, and let's say insertion. In queue data structure, like to insert or to remove an element, we use different terminologies, that is NQ and DQ. Over here as well, I would be explaining only the average case time complexity. Even though if we need to go into detail, we can explore the worst case as well and the best case as well. So for initializing the same thing, like we would be requiring big O of n space complexity. N is the length of the array, and for traversing we just require 0 to n time complexity, and we won't be requiring any space complexity. and NQ is basically insertion of an element. So in the average case, we would be just requiring a constant amount of time to insert an element into the queue, and DQ would also require a constant time. So these are two of the data structure that is most popularly used to implement various algorithms. So these was from my side from today. Thank you, students.